So hello and welcome to you guys. I'm Jerome from Thunderbird, and I work at the Max Clausen Institute. I'm going to talk about the project that we initiated some time ago in Thunderbird. This project is called Cybersailing. So what I'm going to start with is not really get into like heavy details or anything like that, but just simply starting from the title to give you a glimpse or a hint of what we're doing really. You know that like in research we do like quite often a few equations. So what we do mostly, I'm going to present you a simple equation, but not really super simple equation. Cybersailing is actually nothing but sort of can be seen as a sum of cybernetics and sailing together. Of course, you guys might have heard like previously about sailing. But how about cybernetics? Very often when you talk to people about cybernetics, they're like, cyber what? And what I would want to try to convey to you is, okay, what is cybernetics a bit, but also what it is not. Let's start by what it is not. Very often when you hear the word cyber, you hear or you see in your imagination, many people see this kind of thing. Cyberspace, the matrix, and so on and so forth. The interesting about that is that, okay, where is it coming from? This guy, William Gibson, he's the one that he's an SF writer, and in the beginning of the 80s, he wrote these novels like starting or like contributing to what is called the cyberpunk movement in the SF literature. And you can hear that, you can see in his novels that he defined these terms like cyberspace. Also, these terms, when you read the novels, you can read that he's using the matrix as this space that is later seen in the movie. Also, like continue on that, you have other movies that are really attached to this idea of cybernetics, like loosely. Look at it, like if you recognize this movie, like talking about RoboCop. RoboCop is a cyborg, right? What is a cyborg? Cyborg is short for cybernetic organism, right? So, like, but is it really cybernetics or not? Well, I will not try to answer this question, but instead, I will try to show and like tell a bit about like where cybernetics is coming from. This guy is called Norbert Wiener, and he's one that invented the word cybernetics. And he wanted to answer several questions. These questions are related to this very simple problem. What is this problem? You have here a radiator. A radiator is to have the temperature as you want inside the room. So of course, when it's too cold, you turn the heat on. It's you know, not cold enough, you turn the heat down. And how can you do that? Because you actually measure yourself, you feel the temperature in the room. So you make corrections by turning this button on and off. So of course, nowadays we do that by, you know, automatically. There's a sensor and there's a small computer that is actually controlling the temperature in the room. But Norbert Wiener, I mean, like they all, of course, many people, they knew about these things, but he said, wait a minute, when you have some kind of like double temperature is kind of constant. And we all know it's around 37 degrees. When you're too warm, you're going to start sweating and so on. So it means that somehow you have the same kind of behavior. You have the same effect that you're looking for. And what he did, Norbert Wiener, is that he said, I'm going to create a science that will specifically address the question of feedback. Meaning you want to maintain something constant, you have to establish corrections to maintain in these two examples, well, the temperature constant in a room or the temperature constant in a body. And this idea of feedback or using the information from sensors and making corrections was applied to many, many things. One of them being, of course, automation. You can see that in robots, if you have a car, you have these, of course, these electronic stability programs that prevent you from skidding, meaning they measure information to, you know, to actually prevent you from skidding too much. Finally, one of the most advanced things, but you have many, many other kinds of automation that are based on the idea of feedback, is what happens in cockpit, where actually pilots, they still have to do something, right? But like less and less, because everything is actually automated. And you can actually say somehow that this whole thing is coming from the idea of cybernetics initially. So when you go on from autopilots, you can have autopilots for many kind of vehicles. You have, as it turns out, how about these kind of vehicles? This is the question of sailing. This is what we're trying to address more specifically. Take a sailboat. What's the difference between, let's say, you would have an autopilot on a normal ship and an autopilot on a sailboat? How is that different? How is that difficult? Let me show you. You have, why? Because, of course, when you have a sailboat, your direction depends on the wind is coming from. So I'm going to show you, and what's happening is that the trajectory they follow depends not only on the direction of the wind, but the structure of the sail itself. And this is why they have to do these zigzag-like structures. I'm going to show you how it works, but every sailor knows that by, let's release the wind a little bit. So let's take a Danish flag. I mean, the height is because of the ventilator, not because someone is dead, okay? So, of course, if the boat is going this direction, it's going to put some air into the sail. So you will be able to travel this direction. Same thing here. If you travel this direction, you will have air into the sail. However, if you directly face the wind, problem is that it's going to behave more or less like that. Therefore, there will be no force to propel the boat in this direction. That being said, this is intrinsically what makes really making like a totally automated sailboat tricky with respect to, let's say, other vehicles with normal displacements. But you have, so this is a sailing vehicle. You have other sorts of sailing vehicle. Let me give you a few examples of that. You can put a vehicle with a sail, but on a small car. This is what we call a lanyard. And we're going to come back to that later. Other vehicles that had these kind of zigzag-like pattern and that are so interesting to study as well is that, of course, these two things are very interesting because, look, if you take a glider can go up, basically, but with a simple principle, you have a column of rising air, and it has to zigzag up like that. So you see that the same kind of pattern as the tacking maneuver for the ship here. Even more interestingly, this kind of spaceship is what is called a solar sail, where they use, actually, instead of wind, they use the energy provided by the sun rays to actually go, move around. And what is funny is that they use the same terminology as sailboats. They talk about tacking maneuvers, tacking a solar sail, for example. How about, we talk about sailboats now, but think about something. Years ago, we didn't have the engine, we didn't have steam engines, we didn't have like gas or anything like that. We had them, we didn't know how to use them. But so talk about these, let's talk about these boats. These boats, somehow, these ships, I should not call them boats, they had like 20 sails. Sometimes you were talking about dozens of cannons and hundreds of men, like up to 1,000 men in some cases. They were doing everything from they were merchants, they were doing war, they were traveling around, they were going back to the harbor, everything by sail. If you have a, leisure yacht yourself, you know that very often you come back to the harbor, you start the engine, you put down the sail, and basically you're more or less done. What were they capable of doing just by the sail? They had whole treaties of navigation where they could deal with the most tricky situations ever. So here you have a picture of an estuary. If you look at this picture here, you see that, the path is going to be quite complicated. Now take a normal boat. If you take a normal boat, motorboat, you're going to start from here, back into the harbor, for example. Now in the case of a sailboat, you're going to have to do a bunch of crazy maneuvers all around the place. At some point on the top, they go on the side and then they turn. At some point, they even go backwards. So they do all these things, and they can be very tricky. So imagine this now in the concept of cybernetics and automation. You want to do this with a program, a machine that will be able to do it by itself. So how do you do that? So this is the question that we are addressing. What we're addressing is like, can a computer sail totally by itself? Let's say a sailing vehicle, like a sailboat or something like that. But totally, I'm saying totally because, of course, there are some autopilots that you can have on your sailboat. Most of the time, they can do some quite advanced things. But if you're talking totally with any kind of respect, with respect to any kind of weather, this sort of thing, wow, it's really, really tricky. So what we're trying to do basically is to say we use cybernetics together with sailing. By sailing, we mean any kind, these sorts of vehicle that I have been talking about. And this is what we're trying to do, is to make machines or artificial intelligences that will pilot sailing machines. So to do that, we start with, of course, theory to end up with these sailing robots, so to speak. So how do we do sailing robots with combinations of, as usual, theory and practice? Theory is we try to understand what we're going to put inside, how we're going to program these robots. It's coming from first principles, it's coming from also the cybernetic ideas of feedback, but other things. And of course, we were talking about the dynamics, applying these ideas to real robots as well. So let's talk about, like very briefly, about what we do in the theory, what kind of tasks we try to achieve. Of course, we start with a bunch of equations that reflect different things. For example, how are you going to model the particular vehicle you're talking about? How does it move? How you can put its dynamics into a program? That's the question. For sailing vehicles, something that is really important is this idea that we were talking about initially. If you look at this kind of figure, you see that there's a zone where, like this figure is explaining you at what maximum speed you can go depending on the direction of the boat with respect to the wind. And you can see that this kind of dead zone here, where actually the wind has no effect at all. So it's definitely part of our equation, part of how we implement things. And of course, once we have all these things, all this theory, we try to put that into practice by programming for real these ideas, on a computer at first. So I'm going to show you how we do that very briefly. We implement these things on a kind of software and so on. And because you don't want to have problems on your normal boat, you don't want to sink your boat, you don't want to have difficulties either, we try first before trying on the real thing. And this is what we do by simulations. This maneuver tacking, we try it on these things, and this is a simulation of the tacking maneuver. That I took step by step. The wind here is coming from the east. So here is following, cannot go, therefore this way. But however, if I want to go from this point to that point over there, I cannot go this way, so therefore I have to make this kind of small triangle. And there's the moment here where actually there's no effect. Thanks to the because you've seen that on the ventilator, there's no really force propelling the vehicle. So before entering this zone, it has to have enough speed. And it slows down before reaccelerating. This is one of the questions we're studying, and we see that directly in the equation. This kind of effect is what we're looking for, is to predict this kind of effect through the equations themselves. So how about trying this for real now? When we want to try this for real, well, we have the choice between several platforms. I'm going to give you an example of the platform we built is a land yacht. A land yacht is our sailing robot in this case. To build a robot, you need sensors, to know what do I see, where I am, where the wind is coming from. So basically you have this sensor with here, a GPS and wind sensor. You have other things also to move the boat around. So you have an actuator for the sail here, and you have an actuator to steer the front wheel. Finally, you have to have energy for the system with batteries and things like that. You have the intelligence the way we program the thing. So how do we build these robots? And we call this land yacht, autonomous land yacht, MadMax 1. How do we build these robots? Well, we had over the past 2 years, fantastic teams of students in Sunderborg that help us out building these platforms. And I would like really to pay tribute to these guys because, I mean, they're not just good, they just really kick ass. Pardon my French. So one of the things that we do is, okay, we want to give them the feeling of how it is to sail. How is it different from other vehicles and stuff like that? So we take on board, and sometimes it's easy to go around the land yacht. And sometimes it's, you have problems. So far so good, but at some point, it's not always so good. Unfortunately, in this case, he went a bit bad, but not too bad, so that was fine. So, but once they have this idea about, okay, how do we do this? We keep going. All these things that you have seen, they have to conceptualize where are we going to put these sensors, what kind of batteries we're going to put, what kind of actuators, what kind of cabling, and all these things. So this is basically the work they are doing. And after that, of course, you have the testing phase. And we're talking about something really intense. A lot of things are not working, unfortunately. And you have a lot of debugging, reprogramming, recabling, this sort of thing. Here we were on Rømø. This is our test site in Denmark, and it was during winter time. So you can see they were working in the snow, but anyway, I think the temperature was something like -2, -3 or something. And of course, when you are behind the deadlines, you'll also have to work even more. So it's a picture of them like working, I think it was around 2 a.m. or something like that. But finally, they succeeded. So this is the latest version, I would say, of MadMax 1. You can see here is, okay, we're building a robot, but we are trying a platform, okay? So sometimes our programs might not work exactly. In case there's a problem, because this thing can go up to 100 kilometers an hour with the wind, well, you have to be able to correct yourself. The human has to be able to overtake. So there's still a seat for a person with a joystick, as you can see here, and you have a screen and the computer on board the side. What you can see also is attached to the mast is this actuator, which will turn the sail. And this thing is actually right now totally autonomous. We're trying different versions, different algorithms. And the computer programs, they seem to work okay so far, but we haven't tested yet under like a bit more extreme conditions. At MCI, Max Clausen Institute, we're also trying, other type of platform. With our students, we build two dinghy platforms, and they work a bit under the same concept and the same kind of design as you have seen so far. To try different things. What's the difference between on land and at sea, for example? So, but why do we do that for? As a conclusion, I would like to show you small perspective. People think that the use of this, there are several uses of this. Of course, saving on CO2, this kind of thing. But of course, as well, and very important, you have all these small autonomous platforms. You send something on Mars. Mars is so far, you have to be able to, to do something. The robot has to be able to do something because the information back and forth between Earth and Mars is like super slow. So basically, what some people think is like, what if you have a glider? Totally autonomous glider. It would save a lot of energy on one hand, but on the other hand, it has to be sufficiently intelligent to, as you have seen earlier, climb into these thermals, go down, not go on the floor, obviously, this kind of thing. If you think about sailing boats, you know that to observe and to determine, to measure things on the ocean, you have all these buoys that measure things. What you have, buoys that are together with sails, that you put a sail on. You can actually redeploy them. And by redeploying them, you save all the costs by sending crews to take the buoys, to put them at some other places, and so on and so forth. So basically, that's more or less the overview for us. So that might be the future of what we're trying to define as cybersailing. Okay, thank you very much for your attention, and that's it for me. And now for your favorite commercials.